So it's now 3 o'clock, which means that our n-butanol reaction is done. It's time to work it up. So still at 140, the reflux is still nice and gentle. Perfect. Go ahead and put the thermometer away. And now I just want to let that cool. So I'm going to pick it up and just pull out the stirring hot plate. I'm going to put the aluminum blocks in the sink so they can have water run on them and cool down. And as long as I'm careful when I put the hot plate away to make sure that the cord doesn't touch the hot part of the plate, I'm going to turn these temperature and stirring both down all the way. I'm going to turn the stirrer off, and then I'm going to coil this to make sure that it stays underneath the hot plate. Right. And then I can put it away even though it's still hot, just making sure it doesn't melt the cord. And no one's going to come in here and touch it, so that'll be fine. So I need to let that cool a bit, during which time I can run some cold water on these guys. It's a quick way of cooling these guys down so you can put them away without having to wait too long. So now we'll just take those out and let them dry. The extraction solvent that we're going to be using for this is n-hexane. One hex, or just the normal straight chain, CH3, CH2, 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 CH3. Rather than hexanes, which is a mixture of a bunch of different isomers, including some methyl cyclopentane, we're going to be washing it with 5% sodium bicarbonate solution and with just plain water. And in organic chemistry, tap water is fine. So I'm going to grab a couple of pipettes. And pipette bulbs. A couple of Erlenmeyer flasks to stick those pipettes in. And when you put the pipette bulb on, to avoid inverting it, you put it on with your finger and then kind of walk it down. So one of these pipettes is going to be for the hexane, and the other one of these pipettes is going to be for the aqueous materials. And I don't need the spatula anymore, so I can wipe that guy off and put it away. In the lab manual, it says to add your 0.5 milliliter hexane directly to the reaction mixture. I'm actually going to do the extraction in a centrifuge tube, just like I did for the nButyl case, because it's much easier to do extractions in a centrifuge tube. And then in the end, we're going to store our material over sodium sulfate in a conical vial. So I'm going to go ahead and grab a nice clean conical vial and another septum cap. Again, we want the Teflon side, that's the creasy side there. Right, that side down, silicone, which is the side that doesn't crease, up, so that only Teflon comes into contact with our product. We're going to be quenching the excess acid, in this case with the bicarbonate solution. So all we need for our solid is a drying agent. And the drying agent we will use is anhydrous sodium sulfate, Na2SO4. That can absorb up to 10 waters per sodium sulfate to form a decahydrate, so it's very efficient. So just as before, I'm going to pre-fill this. I'm actually not going to even measure out the mass. I'm just going to take a spatula tip full, and filling it up to about the 0.3 milliliter mark of the n-hydrosodium sulfate, and cap that up. So it'll be ready when I have my organic layer to transfer. Still a little warm. We can turn off the water. Don't need the cooling water anymore. And I can go ahead and take my hoses off the condenser. Roll that back. It's easiest to get it off if you roll it. And I'll roll it back on itself. And take the hoses off the condenser. Hoses away. So what I'm going to do is I'm going to transfer the entire contents of the vial to a centrifuge tube, and then I'm going to add probably about a milliliter of hexane. Basically, I'm not going to measure it. I'm just going to take one pipette squirt, which will be about a milliliter. And I want to be a little careful because those are concentrated acids. So it's probably a good idea to wear gloves. Even though it's harder to work with gloves on. Okay, so that comes off nicely. Woo. And I just dumped it on the bench. So you will learn how to do a benchtop extraction. I'm going to suck up as much of that material as I can so I don't lose a lot of compound. And we'll still get away with it. It's mildly annoying, but it's not fatal. This is why I put my gloves on. Go ahead and transfer everything I got, which is a little bit less than I used to have. From the vial into a centrifuge tube. Yeah, fortunately we didn't lose it all. And we don't need very much for the GC analysis, so the fact that I dumped most of it won't end up being fatal. It's always the long reaction that you dump, right? Never the short one. Let me wipe that up. Alright, so I've got probably about 1.5 milliliters left out of the 3.5 milliliter that I should have. It'll be plenty. But now I probably don't want to add quite as much hexane as I was planning on adding. So instead of adding a full pipette, I'm going to add maybe half a pipette. And I'm going to mix that well. What I'm trying to do is extract the organics, the alkyl chloride and the alkyl bromide, into the hexane layer, leaving the aqueous layer behind. So, have a couple of mixes, vent it. I'm going to let that settle because I want to remove only the bottom aqueous layer, which is what I kept this syringe for. That settle a little bit more. And I'm going to need to do a water wash with about 1 milliliter of water. So I'm going to fill the vial. That'll be my source of water when I do my aqueous wash. So now what I want to do is carefully remove the bottom layer. And that's why we're doing this in a centrifuge tube, because you can remove the bottom layer more easily when you have that really nice tip. And it's not critical that I remove every last bit of it, because I'm going to be washing with water anyway. What I don't want to do is accidentally remove some of the top layer. So it's mostly gone. And now I'm going to add 1 milliliter of water. We're at the 4 ml mark. It's about 1 milliliter. And that's going to get a lot of the residual acid out. And I'm going to mix that back and forth. And vent, release the pressure. Mix it back and forth. Vent to release the pressure, and I'm going to let that settle again. And don't want to lose my spin vane, so I'm going to set that aside so it doesn't accidentally go down the sink. And while I'm waiting, I can take my condenser out. Put the clamp back. Grab a little micro spatula. A micro spatula is a good way to grab that O-ring. Pull it out of there. That should have settled. And once again, I'm going to remove the bottom layer. It's important, or a good idea anyway, to depress the pipette bulb first, so you don't end up blowing the bunch of air in. Let that fill up. And again, It's more important to make sure I don't lose the top layer. And now since this pipette is dry, since all it had in it was the n-hexane, I can use it to measure out sodium bicarbonate. I want about 1 milliliter. That's about right. And that's going to get any residual acid out. Give it a vent. Mix it back and forth. Let it vent. And now we're going to let that settle. Don't need this pipette anymore. That was the one from the acid. But I will need a clean and dry pipette to remove the organic layer onto the drying agent. That is probably wet because it had the wet pipette in it, so I'm not going to set it in that one. It's still a little cloudy. We're going to let that sit. These guys away while we're waiting. And I'm going to put the bicarbonate away, which goes in the back of the room here. And the n-hexane, which goes in this cabinet here.